All right. So the very first thing I would have done is I need to make sure all of my arcs have been found before I do anything. So if you look, letter T is actually asking you to find the measure of SQ. So this arc right here. How would I find it? Right. I would take all the other three arcs, add them together, subtract from 360. So if you do that, you should have gotten 85. All right. So this arc is 85 degrees. And the reason you want to make sure you have all of your arcs is because if you don't, find these angles are going to be pretty difficult. All right. So remember what I said yesterday. You just want to go through all your different subtypes. Okay. So I'm going to start with beaks because there's not as many of those. So let's do beaks first. Someone raise your hand and tell me one beak. Number one's a beak. How'd you find it? All right, so if you look right here, you do major minus minor and divide it by 2. Well, the major arc is the 150 plus the 85. So that would be 235. And subtract it from your minor arc, which is the 85. And then divide by 2. So that's 150 divided by 2, which is what? 75. So angle 1 is 75 degrees. What's my other beak? 11. So how do I find 11? 150 minus 40. So that'll give me 90. All right. Nope, that'll give me 110. I know. I did it wrong. So 150 minus 40 divided by 2. That's 110 divided by 2, which is 55. So 11 is 55 degrees. And that's all of my beaks. All right. Now let's do bow ties. So someone name me one set of bow ties so that it be congruent. Follow. 16, 17. All right. So if I do 16 and 17, since they are vertical angles, they will be congruent. How do I find them? Right. You do arc of 17, arc of 16, add them together, divided by 2. So this will be 40 plus 150 divided by 2. So that's 190 divided by 2, which is 95. So both 16 and 17 are 95 degrees. What are my other two bow ties? 1918. How do I find them? 85 plus 85 over 2. So that'll be 170 over 2, which would just be 85 because you're adding the same number twice anyway. So both of these are 85 degrees. Everyone good so far? All right, now we're just going to do inscribed. So there's a lot of inscribed. All right, so someone name me one. So let's do 3 first because that's what I heard first. So 3 is inscribed. So it's right here. What's its intercepting arc? 40. And how would I find it? 40 divided by 2. So that's 20. So angle 3 is 20. Angle 2 is also inscribed because it said that LM is tangent to the circle. So since it's made from a tangent line, it's also considered inscribed. What's the intercepting arc? 85. So you just do 85 divided by 2, which is, should give you a fraction or a decimal. Right, 42.5. So for 2, you did 85 divided by 2. So that'll be 42.5. Another inscribed, someone who hasn't talked yet. Yes, 5 is inscribed because, again, it's tangent. So what is the intercepting arc? 150. So 150 divided by 2 is 75. Another inscribed, someone else. 6, I'll take 6. All right, so 6, what's its intercepting arc? 85, so it's the exact same thing as 2. So it'd be 42.5. So what's great about these guys is you'll start to see a lot repeating. Another inscribe, someone else. Say it again. I heard 4, all right. So 4, intercepting arc is what? 85, so it's the same as 6 and 2. So it's 42.5. What's another one? All right, I heard 9. What's that one intersect? All right, so it's the same as all the others that we've done so far. So it's 42.5. Mm, 10 is not. 13, yes. 13, what's its intercepting arc? 85. So it's still 42.5. I did hear 14. We'll do that next. All right, so 14, what's the intercepting arc? 150, so it's the same as 5. So 75. 10 is not, because it's not coming from a tangent line. 7 is. All right. So 14, I didn't write this down. No. 10 is one of those special ones where we have to use the triangle. All right, so 7, what's the intercepting arc? 40, so it's the same as 3. So 20. So hold on. Okay, 15, no. 8, yes. So 8, what's the intercepting arc? 150. So it's the same as 14 and 5. So it would be 75. All right, now we've done all of the inscribed. Because 15, 12, and 10, they're technically not inscribed because they're not formed by a tangent. They're formed by secants. All right, remember, an inscribed outside of the circle, or like that's kind of weirdly outside the circle, has to be formed by a secant and a tangent together. Since both of these are both secant lines, we can't say that they are inscribed. But we can use the skills that we learned yesterday. So for 15, how do you think I would find 15? So remember, we use different shapes and different other angle properties to find them that are not just circle properties. A triangle, that'll work. So we can find 15 through the triangle. So in other words, I add up 75 and 42.5, subtract it from 180. So what would that give me? $62.5. Good. So 15 would be 62.5 degrees. All right. Now, so number 12. All right. So with number 12, there's 2 ways. What would be the easiest way? Because we can't really do the triangle yet. But what was the other way that I did it? The supplementary. So if you look right here, it's on this straight line with 13 and 14. So I would just have to take 75 and 42.5, subtract it from 180, which is what we did here. So it'd be the same thing as 15. So that's the triangle dash supplementary. So it'd still be 62.5. So now we can find 10 because we got the completed triangle now except for one angle. So for 10, I would take 180 and subtract 55 and 62.5. to get 10. And what will that give me?
I got a 62.
62.5. Good. So it would be 62.5. And we've completed our big circle. So guys, remember, when it comes to big circles, you've got to first off make sure all the arcs have been found, because that's the easiest place to start. Then after that, you just pick a subtype and go with it. All right. So I recommend going through all 3 subtypes first. So beaks, inscribed, and bow ties. And then whatever angles you have left over, those are the ones where you start using triangles and supplementary stuff, because by then you should have enough information to do them. All right. And remember, you will have one of these on your test. So we'll have some more practice with this later when we start reviewing. I will give you some big circles to practice with. All right. But you got to get decent at them, because you will have one of these on your test. All right. Not as massive as this one. I think like the one on the test is like maybe 10 angles you got to find. All right. Okay. So now we're getting out of angle land and we're going into segments. So far we talked about how to find angle measures. Now we're going to talk about how to find segment lengths. So go ahead and take out your journal and go to that first foldable. So the one that says arcs and chords. So it's this foldable. The one with the 3 circles on the front. Now, if you haven't grabbed a calculator already, you might want to grab one. You're going to need it. So we're on this foldable. It's the one with the 3 circles on the front. It also says arcs and chords. Other way. Other way. All right. Shh. If you have your Chromebook out, please close the screen. You do not need it right now. All right. So we're getting away from angle measures and we're actually looking at the lengths of segments. All right. So basically all 6.5 is finding segment length. So units will be things like meters, feet, centimeters, things like that. All right. It's not going to be degrees anymore because we're not finding angle or arc measures. So looking at this first one, let's look at the first theorem. And it states, in a circle or congruent circles, 2 minor arcs that are congruent if and only if their corresponding chords are congruent. So we kind of saw this a couple of days ago in our notes. So what that means is that if we look at this shape here, okay, let's call this A, B, C, D. All right, so I'm just labeling the points. We kind of get an idea what's going on. So if you see here, segment AB is congruent to segment CD. So segment AB is congruent to segment DC. So those segments are congruent. But on top of that, the arcs formed between those 2 points are also congruent. All right. And it makes sense because, like I said earlier, if you have a certain designated length of space. All right, so let's say this was like an inch. All right, that means that however much an inch is from one end of the circle to the other, that arc piece should be the same on either side. All right, so on top of that, the measure of arc AB is congruent to arc DC. All right, and it's only those two arcs because if we look, the ticks. All right, so if I wanted to mark these with ticks, I would just use one tick to mark those arcs as congruent. Now, why would AD and BC not be congruent?
They're different type, like their measurement.
Right, their measures are different. How do you know their measures are different? They have different number of ticks, right? So remember, it's a matching game when it comes to the ticks. They have to have the same number of ticks in order for it to be congruent. So on the other hand, the arcs would also not be congruent. So let's look at examples 1 and 2 in terms of that theorem. So for number 1, it states that segment AB is equal to 5x. So I'm going to go ahead and label that. And segment CD is 3x plus 6. And it wants us to find the length of AB and CD. So first things first, we got to solve for x. Now, if you look, they also gave us the measures of arc AB and arc CD. And what's true about those two arcs? They're congruent. So we can say that arc AB is congruent to arc CD. So since the two arcs are congruent, what does that say about the segments AB and CD? They're also congruent. So if these two segments are also congruent, how do you think I'm going to solve for x first? Set them equal to each other. So I get 5x is equal to 3x plus 6. So I'm going to subtract 3x over. I get 2x is equal to 6, so x is equal to 3. Now, that's not my answer because what it asked me to find? A, B, and C, D. So what do I need to do to find it? Plug in the 3 in for the x's. And since they are congruent, we only need to plug it in for one of them. So since A, B, and C, D is congruent, right, I'm just going to plug it in for A, B because that's the easier one. 5 times 3 is 15. So 15 is the length of A, B, and C, D. If you want to check for C, D, 3 times 3 is 9 plus 6 is 15. So it still works. So guys, if this was on your test, please make sure that you answer the question fully. All right, so sometimes solving for x is just the first step. All right, look at number 2. So it says to find the value of x. All right. Now, just for our own sanity, you can label any kind of shape within a circle, anything you want. So I'm going to label it ABCD. So they gave us the arc measures of AB, BC, CD, and DA. Which two arcs are congruent? So there's 2 congruent arcs on here. What are the 2 congruent arcs? AB and CD are my congruent arcs because they're both 80 degrees. So AB is congruent to CD. So what does that say about their segments? They're also congruent. So since these 2 segments are congruent, what do you think I'm going to do? Set what equal to each other? Right. I'm going to set 12x minus 2 equal to 34. So this is one of those questions where they give you more information than you actually need. You don't need this 56. You don't need this 78. You don't need this 50. You don't need this 150. You just need what I haven't crossed out. All right. So problems like this, especially if it's on the EOC, they like to do that. They add more information than what you actually need because they want you to see if you can decipher through what information you'll actually need. So I'm going to add the 2. 12x is equal to 36. Divide by 12. What's 36 divided by 12? 3. And since they said to find x, we can stop at x is equal to 3. Any questions on 1 or 2?
Nope. Okay, we can move on to the next one.
You guys good? Can I move on? All right. Okay, let's look at the next theorem. So in a circle, if a diameter or radius, so in other words, it goes from center to edge, or it's a segment that goes through the center. If it's perpendicular to a chord, all right, so remember a chord is just a segment that goes from one end of the circle to another, but it doesn't necessarily go through the center. That's the difference between a chord and a diameter. Then it bisects the chord and its arc. All right, so this word right here, we've seen it a lot. Bisects. What does that mean? Cuts in half.
It goes in half. It goes in half. It goes in half.
Cuts in half. So in other words, so if it cuts it in half, what does it create? 2 congruent pieces.
Right.
So what does this mean? All right. So what happens is that this is the radius right here. And this is the chord. And if you notice, it's perpendicular to that chord. Since it's perpendicular, that means the radius bisects the chord, which means that at the point of intersection, this piece is now congruent to this piece. It also says it bisects the arc. So this arc right here that's made up from the chord, both of those two pieces would be congruent in measure as well. Now, some questions that you may see with this is sometimes, what happens if I draw 2 more radii?
You have 2 right triangles.
I have 2 right triangles. All right, and remember these 2 pieces would also be congruent. So if I draw these radii or radiuses, if I draw a radius to make a right triangle. So if I was asked to find some segments, what do you think I would use? So finding segment lengths with right triangles, what we typically use? The theorem. Pythagorean theorem. Good. So you will see some problems similar to this where you will have to use the Pythagorean theorem. So it's just a good idea to note that. So a squared plus b squared equals c squared. Shh. All right. So let's look at examples 3 and 4. All right. So example 3. Given chord BC is 15 centimeters from the center of the circle, which has a radius of 25 centimeters. Find BC and DE. So what it says is given that BC, so this entire chord right here is 15 centimeters. Wait,
You
what?
already got a right triangle, though. Stop fighting.
Okay, so this is a typo. You're supposed to be finding BD, not BC. So we're going to find BD and DE because they already gave us chord BC. No, I'm showing you how to do this. So this will be 15 centimeters. They then said that the radius, what segment's my radius on here? AB, and then also what?
AD,
Not AD,
BD.
AE. So both AB and AE are 25 centimeters. And it wants us to find BD. So it wants us to find this segment right here. And it wants us to find this segment right here. So DE. So which segment do you think will be the easiest to find? BD or DE?
BD.
BD. Why?
Yeah.
It bisects. Good. So if we know that BC is 15, how do I find BD? Divided by 2, because these are equal pieces. So if I do BD is equal to 15 divided by 2, which would be 7.5.
Yes.
So this would be 7.5 centimeters for BD. So I want to label it right here. Now, let's come up with a plan to find AD, or not AD, DE. So DE is just that little piece of the radius of AE. So I know that the radius AE is 25. How do you think I can find DE?
Split it into 2. Divided by 2. Can I? What you say? Why? Give me 2 reasons. Stop playing. That's smart. Giamara is like. Tiana Johnson. There you go. Giamara is. Why is it on speaker mode? We're finna hear everybody's video. I want to hear. Yeah, I should leave.
It was Tiffany. I know this name.
Reach your Tiffany. Giamara Perez from Mississippi. Manifesting. You look that What are you waiting for? You're not leaving.
The best way to reach us is via email.
Okay, so
What if I'm leaving and you don't know?
Miss Mayo, you ain't leaving.
All right, so if it's important, she'll email me. All right, so how do you think I'm going to find DE?
So you can't divide it by 2.
Nope.
Hey, just put it on speaker mode at this point. Shh, guys.
Okay, my phone. Whatever. Did you try unplugging it?
Unplugging it back in. Did you try beating it?
Yeah, it's been beat before.
I told you. At this point, just send Cam to pick it up every single. Dude, I've been so scared to end up pulling out. I don't even curve for real.
All right, so okay, so to find DE, we actually need to find AD first. Why do you think I need to find AD? It's a piece of it. So if I can find AD, because I already know that AE is 25, I can subtract the two to get DE. So how can I find AD?
25 minus
What's this?
a triangle.
What type of triangle?
A right triangle.
Right triangle. Do I not have two sides of that triangle?
Yes, you do.
Yes, I do. So what can I do? Pythagorean theorem. Good. So I would do 7.5 squared plus AD squared. That's equal to 25 squared. So what's 7.5 squared? 56.25 plus AD squared is equal to 25 squared, 625. All right.
Math teacher.
Gee, I wonder why. All right, so then I subtract the 56.25. So can someone do that in their calculator for me?
568.72.
568.75. Then you square root both sides. What do you get?
How do I square root? 153.72. Well, 173.
Isn't it 23.84?
Square rooting it?
Square rooting it. Because it's 568.
Oh, you gotta be kidding me.
I think I figured.
I don't know.
I
Gives you the distance
It's so full in this room.
I know I gave you the distance of AD.
He's just a baby.
Okay, so in reality, this is 15 because I labeled this wrong. So we are finding BC.
Bro,
Miss Murphy made an oops. It's
guys,
fine.
calm down.
So guys, if you have this, just leave it as is. But just know that you'd use Pythagorean theorem to find BD. So I'm just gonna tell you what it is. So BD is 20. BD is 20, so that means BC is 40. And DE would be 10. Okay, it was my fault, but you still use the same processes that we just did. Okay?
Everybody
Wait. You should give us snack time.
No.
Okay.
Okay, so sorry about that. Don't worry about it. No. After we finish this foldable. All right, so now we're going to find AD and CD in the measure of AB. All right. You'll be fine. Okay, so all right, now AB is actually pretty easy to find because here's this arc. Can't we find a piece of this arc because of this angle right here? What type of angle is that? It's a central angle. So that means AE would equal what? 60. Now, what's true about it splits the arcs in half, so these two pieces are congruent. So EB is also 60. So what's the length of AB? 120. Now, as for the rest of it, we kind of have to use something you learned back in math too. So, please stop. What type of right triangle is this? So if this is 60 degrees, this is 90 degrees. What's this one? What's this angle? 30. Do you guys remember special right triangles?
When do we do?
Math 2.
Yeah, I
So
learned
it's a
anything.
30, 60, 90 special right triangle. So all that says is that if you have a right triangle and you have 60 degrees and 30 degrees, all right? So this is your hypotenuse. This is your short leg, and this is your long leg. All it says is that if your short leg is some length x, your hypotenuse would be twice the short leg, and your long leg would be x times the square root of 3. All right? And so you would go this way. So 6 is our what? So 6 right here. Is that our hypotenuse, our short leg, or our long leg? It's the hypotenuse. What would our short leg be? So it's always the one across from the 30-degree angle. So what side is directly across from the 30-degree angle? Guys, side. What's the name of the side? How do we name sides? How do we name sides, guys?
Angle side angle.
How do we name sides? With two. It's CD, thank you.
Wait,
name
I
it
was
with-
like partially right.
You name it with 2 letters. So, this is my short leg, and this will be my long leg. So, how does the hypotenuse connect to the short leg? So, if the short leg is x, the hypotenuse is 2x. So, how do I go from hypotenuse to leg? Short leg's half the hypotenuse. So, how would I get CD? 6 divided by 2. So, that's 3. So, CD is 3. Then how do I get AD? Multiply that by the square root of 3. So it's just 3 square root 3. So these are our answers. All right, last theorem and then we'll go on break. So if 2 chords are congruent, it's only if they are equidistant from the center. So what does equidistant mean? Same distance. So same distance. So, So if you look, these 2 lines right here represent the distance from the center to each chord. All right. So that means that these 2 chords are also congruent. Now, same thing. Sometimes you'll see some right triangles in here. So just draw radii. All right. Now, let's look at let's look at 5 and 6. So FG is 3, GA is 5, and AH is 4. And they want us to find PJ and LA. All right. So first off, some of these we can already figure out. All right. So first things first. All right. I need to find GH. Okay. Because why do you think I need to find GH? What's important about that?
It's in the middle.
Oh, wait, it's
My man's X lives there.
Yeah, it's the other side. It's the big line.
Well, I need to check that these two segments are what? Equal. Why? Here's the center of the circle.
Oh, wait. That would
We gotta make sure that they're equidistant from those two chords, so then we can say the chords are what? Congruent. So first we gotta check that FG is congruent to GH. So I'm gonna do Pythagorean theorem to solve for GH. So I have 4 squared plus GH squared is equal to 5 squared. So 16 plus GH squared is equal to 25. Subtract the 16. I get 9. And then what's the square root of 9? 3. So are they congruent? Yep. So since these are congruent, we can assume that PJ will be congruent to LA. Now, we do have enough information to find it because let's say I drew a radius from G to L. What would this radius be equal to? Nope. 5, because GA is also a radii. So this is also 5. So if this side's 3 and this side's 5, what has to be this side? Didn't we just do a Pythagorean theorem with a 5 and a 3 and a 4?
Yes.
So this side has to be 4. So what's the length of LA? 8, which means PJ is also what?
8.
So it's equal to 8. All right. Last one, then we'll go on break. Promise. Technically, don't have to give you a break if I don't want to.
I'm gonna need you to be quiet.
All right. So FG is 3x minus 14. HJ is 14. Find the value of x. So this is an easy setup because what's true about those two chords? Why? Right, they're both 2 units away from the center. So these chords are congruent. So how do I set up my equation? 3x minus 14 is equal, or not 14, 4, sorry. 3x minus 4 is equal to 14. So I add the 4 first. 3x is equal to 18. What's 18, what's 18 divided by 3? 6. So x is equal to 6. All right, you guys can go ahead and take your 3-minute break. When we come back, we're going to do the other foldable.
Harris, what do you do? Sit over here.
There was one on the side.
No, it was on the wall. I couldn't.
Shake right. Yes, yes.
Right. Went grocery shopping yesterday too. Just sneak that shit. Put that shit in your food and start eating.
Please quit that shit, bro. Please, for the love of God.
Make a beat. Ready? Ready? We can stop each other. Bro. We have like 7 seconds.
All right, guys, back to it. All right, so let's look at that second fold bool. So this one has to deal with secant lines and tangent lines. So the very first one is, if a line is tangent to a circle, then it is perpendicular to the radius drawn from the point of tangency. So what that means is that, remember, the point of tangency is the point where the tangent line intersects the circle. So that'll be right here. All right. So that means that where this radius and this tangent line intersects, it forms a right angle. All right. So again, this is the tangent line and this is the radius. So guess what? If we had to find these segments, what do you think we're going to use if it's a right triangle? Pythagorean theorem. So a squared plus b squared is equal to c squared. And again, it's because we have a right triangle. All right. So let's look at that first example on. Well, actually, before we do that, let's look at the other theorem. So the other theorem states, if two segments from the same exterior points, all right, are tangent to a circle, so in other words, they intersect outside the circle, then they are congruent. So if you notice, both of these tangent lines intersect at this point, meaning that these tangent lines are congruent. Now, a lot of times how you'll see this is they'll draw another segment between, it is technically a beak, but we're not finding angles, we're finding segments. So they would draw a line from the center to where it intersects outside the circle. They would also go ahead and draw the radii from the points of tangency. Which, what we just learned about radii and point of tangency, they form what? So where the radius and the point of tangency, what they form? It forms a right angle. So both of these triangles are what? Right triangles. Now, remember, the radii are congruent. And then what would happen with this segment right here? So what's true about this segment for both triangles? It would be what to itself? Congruent. So aren't these two triangles congruent?
Yes.
Yeah, because side, side, side. So it also forms two congruent triangles. So, in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So what they want us to say here is that line L is tangent to the circle S if and only if the line L is perpendicular to ST. Which it is, because it marked that. So, oops. It's saying that this angle right here is a right angle, so it's 90 degrees. So what would be my point of tangency? So in other words, what point does the tangent line hit the circle? T. So the point of tangency is point T. All right. If we look over here, if two segments from the same exterior point are tangent to a circle, then they are congruent. So if QP and RP are tangent to the circle, then we would say that QP is congruent to RP. That's exactly what we were typed in, not type, right down here. They are congruent because they meet at the same point of tangency. Not the point of tangency. They meet at the same exterior point, and they form. Right. Yeah.
Can that give us two?
Yes. If we drew the radii, these would also be right angles. So remember, two congruent triangles there. All right, so we're going to answer these last 6 questions, and then we'll be done. Not forever and ever till tomorrow. All right, so use the diagrams for the questions where MC and MZ are tangents to the circle B. So these two lines are tangents to the circle. So based off of what we already know, let's just go ahead and mark some things that we already know based off of what we know. So we know that BZ is a what? Radius. BC is also a what? So they're what to each other? Now, we know that MC is a tangent line. So the point of tangency is point C. So what is BC to MC? They're what to each other? Nope. Perpendicular. So they form a right angle. The same thing would be for BZ and MZ. Now, since MZ and MC intersect at point M, that means that MZ and MC are what? Congruent. Now, BE is also what to BC and BZ? Congruent. And same thing with BX, they're also congruent. Now, why am I marking all this? Because it'll help us answer these questions. So, we're going to find the measure of angle BMC. And we already did. What is it? 90 degrees. Now, number 2, we're going to find the length of CM if CM is equal to 5x minus 9 and MC is equal to x plus 7. Well, what's true about those two segments? So CM and MC, they're congruent. So how do I set up my equation? Set them equal to each other. So subtract the x to both sides, add the 9 to both sides. So I get 4x is equal to 16. So x is equal to what? 4. Now, that's not my answer because what they asked me to find? The length of CM. So I'm going to plug it back in for the 5x minus 9. So 5 times 4 minus 9. 5 times 4 is 20 minus 9. CM is equal to 11. Now, I would not mark it on this because these questions, none of them connect to each other. All right, so I would not mark it on the circle. Now, it then says that find the length of EM when CM is 12 and BC is 5. All right. So I'm just going to draw what's going on. Okay. So this is the triangle BC, E, and M, where the circle is like right here. All right. They said that BC is 5 and CM is 12. Now, what's true about BC and BE? They're both radii, so they're both 5. So first off, I need to find BM first before I can find EM. How can I find BM? We have a right triangle and 2 sides. So we can use what? Pythagorean theorem. So if I'm finding BM first, I have 12 squared plus 5 squared is equal to C squared. So that's 144 plus 25 is equal to C squared. 169 is equal to C squared. Square root it. BM is equal to 13. So if all of this is equal to 13, what's EM equal to? So BM is 13, BE is 5. So what's EM? 8. You just subtract them. Because we did 13 minus 5, and that's equal to 8. All right. So if angle CBM is 60 degrees and CM is 13 square root 3, find the length of BC. So I'm just going to draw this triangle. So BCM, it says that CBM is 60 degrees. Just draw arrows. Yeah. Yeah, I don't care.
But I care.
Okay. So if this is 90 and this is 60, what's the other angle? 30. So this is another special right triangle. It's a 30, 60, 90. So remember, special right triangles, short leg, hypotenuse, and the long leg. Short leg is x. Hypotenuse is 2x. Long leg is x square root 3. So it said that CM is 13 square root 3. And they want us to find BC. So let's call that x. Is CM my short leg, long leg, or hypotenuse? Is it across from the 60-degree angle, the 30-degree angle, or the hypotenuse? Or the 90-degree angle? It's across from the 60, which means it's the long leg. So the long leg is equal to x times the square root of 3. So how do you think I'm going to find BC, which is the short leg? Not subtract. Divide by the square root of 3. So I'm going to do 13 square root of 3 divided by the square root of 3. What happens to the two square root of 3's? They cancel. So BC is equal to what? 13. All right. Number 5. So find the length of CM if BC is 12 and BM is 20. Okay, so again, we got that right triangle. This is BCM. I'm just redrawing what's in the picture right here, guys. All right. And they said that BC is 12, BM is 20. So how do I find CM? Let's call that X. Not BM and CM, because if you look, BM is here and CM is here. But I can use what theorem to help me find this? Pythagorean theorem. So I'm going to do 12 squared plus x squared, because it's not a hypotenuse, it's a leg, equal to 20 squared. So it'd be 144 plus x squared is equal to 400. Subtract 144. I get x squared is equal to 256. Take the square root of both sides. CM is equal to what? Anyone know what the square root of 256 is off the top of their head?
16.
16. All right, last one. So find the length of XE if BM is 25 and ZM is 20. Now, since it's the last one, I'm going to mark up this picture. So we're finding the length of XE. So this right here. If BM, so if this length is 25 and this length is 20. Now, XE is considered the what? It's the diameter. So in order to find the diameter, I need to find the what first? Radius. That's equal to twice the radius. So is it true that BC is also a radius?
Yes.
So if I find that radius, I can double it and get XE.
Yes.
All right. So again, we use Pythagorean theorem. So I have 20 squared plus x squared is equal to 25 squared. So that'll be 400 plus x squared is equal to 625. Subtract the 400. X squared is equal to 225. So what's x equal to? 15. That's if you square both sides. So this radius is 15, which means this radius is 15 and this radius is 15. So in other words, what's the length of XE? 30. It's 15 times 2. So XE is equal to 15 times 2, which is 30. Now, I know that was kind of rushed, but we will do a lot more practice with this tomorrow because we only have one more foldable. But more often than not, guys, when it comes to segments, more often than not, you're going to be doing Pythagorean theorem in some shape or form. So a lot of the segment stuff revolves around Pythagorean theorem.
Adam.